Here is a question that gets asked in almost every interview. How does HashMap find a value in a constant time O1? Not O log n, not ON, O1. No matter how many entries you have inside. To answer that properly, let's first look at two data structure you already know really well. Array and linked list. Let's start with array. If I give you an array and I ask you, get me the value at index 5, what do? You just jump straight to the ARR of 5. No searching, no scanning. Like we directly access the value here. And this is what gives us O1, but only by index. We need to know the index. Otherwise, we won't be able to access the value. We cannot access the value using any other key like string or any other object. Now, let's look at linked list. Now, in case of linked list, if you see, we have list of element which are linked with each other and we have only access to head. So even if we can search and find with different type of key like string, etc., if we want to find an element in linked list, we need to scan the entire list, which takes literally on, and we need to scan everything. Now, what if we want to use any key as well as we need O1 access? What can be done? So this is where HashMap comes into the picture. So what is the trick here? Basically, how does HashMap get O1 by using the key? So basically, what does HashMap do is, at high level, it converts a key or any other object that it uses as a key into index of an array so that we can retrieve with index. So that is the trick in a HashMap. Now, let's look at the example and see what happens inside the HashMap. HashMap internally has an empty array or initializes an empty array of size 16 when HashMap is created. Each element of this array is called as a bucket. Now size of this array starts as a 16 and later on it gets resized. We will discuss that in another video, but for now let's focus on what happens when we call say map.put with key and value. Now we have the key here, and as we have seen, there is an array of buckets here. Now, in order to get to the index of this bucket, what happens is first the hash code on the key is invoked. Now, when you invoke hash code on a key string like a Java, it gives us a long value. However, this value is very big and we cannot map it to any bucket because the size of the bucket is 16. So how does that happen? So then we use mod 16 internally to get the value which is within the 16. So here for this number, the modulo operator gives us a 9 as a value. Now the map.put puts this value at the index of 9. So at the index 9, the entry with key and value is stored. Now what happens when we try to get this value? So when we try to get this value, again the same process is repeated. So again the key is used to get to the value of the index and using the same hash code and modulo 16 operator. And once you have this value 9, then value is retrieved. But once in the bucket, we use equals to get the value, to get the exact value from the bucket. This is the reason we have hash code and equals on every object, and we need to make sure that when we are overriding equals, we should override hash code as well, such that it is inconsistent with the equals method. Now consider that another map.put is called on the same map, say with another key Kafka. So again, same step would be repeated, like the hash code would be calculated, and since hash code value is long, we will do modulo operator to get to the index. Now this time the index value is 3, so the value is stored on the index. And same step is repeated, that map.get Kafka would retrieve the value. Now if you see here a pattern, like we have only 16 buckets and we could have more keys. So there would be a case where collision would happen. So let's look at what if we are trying to put another value and whose hash value comes as a same as that of the existing value. Say it is a 3 again. Then what happens there? In that case, there is a linked list is created at the bucket 3, and the value is stored as a next value on that list. Now in this case, when map.getSpring is called, what happens is the value, the map.get would go and first look at this 3 index. It will start looking at the 3 index. Then it will use equals to check each value in this list one by one. And whenever it finds the spring as a value, it will return that. So what we see is, in case of collision, the list is created. Now usually the hash function is very good and this list never goes longer. But what if your hash function is not good and like multiple keys are mapping to the same bucket? In that case, what would happen? This list would keep on growing. Like for every bucket, there would be more and more list. And it can keep on growing like this. And what would happen then? Then say for any value to be retrieved at index or bucket 3, we will have to then scan entire linked list. Like, and we are reaching now the time complexity of on. Of course, it only happens when your hashing function is bad, but there is still possibility to have such scenarios. Now, to solve this, Java 8 has introduced a new thing. This is only happening since Java 8. And what happens is that Java 8 has added a threshold of value 8. And whenever your list goes beyond that size, it is converted into a tree. So in Java 8, this is a red black tree is created if your linked list goes beyond the size 8. And this gives us time complexity very less than the O of n. This only happens when your chain size is greater than 8 and your array of bucket is greater than 64. Now I have taken an example of 16 here, but in practical scenario, whenever your array size is greater than 64 and your chain is getting, your linked list is growing beyond 8, that list would be converted into red black tree. And this would give us a time complexity of O of log n. In this way, in a worst scenario where even if your hashing function is not working fine, you will still get a better retrieval. So what have we seen so far? So in summary, first thing is whenever a hash code is used to find the index of the bucket. So in HashMap, hashcode, we use hashcode to find the index of a bucket, and which gives us O of 1. Second thing is whenever there is a collision, the chaining happens and linked list is created. Now hashcode is used to find a bucket and equals finds a key. This is very important. So hashcode value on an object is used to find a bucket and equals find is used to find actual key location in the further list that is created. And last most important point, the Java 8 has introduced a tree file. So whenever the chain size goes beyond 8, we still get now a O log n instead of On complexity. So if you have watched this video so far and enjoyed it, please let me know in comment and do not forget to subscribe and like the video. Thank you.